Okay, so chapter 11 is rational expressions. When we talk rational, we're talking about something that can be expressed as a fraction. Okay? So notice everything on this page is a fraction. If you flip through your notes packets, things are fractions. Okay? So it's all about how we deal with rational expressions. And I just made you a little unhappy, didn't I? I'm sorry. Okay. So, with that in mind, though, today is about simplifying them. Okay? As we go look at example 1, okay, 21a squared over 7a cubed. Think of terms of simplifying a fraction. What do they both have in common that we could divide by?
A 7.
They have a 7 in common. And what'd you say?
A squared.
A, but specifically they each have at least a squared, right? So always go with the lower of the two exponents is what it comes down to. Okay? Put the IXL aside, all along the notes, okay? So one way to do this problem is that we can divide both top and bottom by 7a squared. Because we said they both have a 7 in common, they both have an a squared in common. So on top, what is 21a squared divided by 7a squared? So 21 divided by 7 is 3. And what about a squared divided by a squared?
Just A.
It's A, right? Because you subtract when you're dividing.
So if we subtract those powers, on top it's 2 minus 2, which is
Just nothing.
0, so that means your a's cancel out. Because a to the 0, you don't even write. So 21 divided by 7 is 3. And because the a's have the same exponent, we cancel out, we don't need to write it. Okay, denominator. 7a to the third divided by 7a to the second.
7 is just 1.
Okay. 7 divided by 7 is 1.
Yeah, and the A is just A. It's just A.
Okay. A to the third divided by a to the second. Keep the a and subtract the exponents. 3 minus 2 is a to the first if I want a power there. But I agree, just a. Yes? And so how I would write this is 3 over a. Not that 1a to the first is wrong, but those ones are unnecessary. Now, I'm trying to think, is the wording the same in Math Excel? I don't remember. But notice up there, besides simplifying each expression, we also, in lesson 1, focus on state any excluded values. So any excluded values would be numbers that we put in for the variable that make this fraction not exist. When can a fraction not exist? When the denominator is 0, right? So notice what it says over here is for excluded values, this is kind of your hint that we're going to set the denominator equal to 0 to find those excluded values, because ultimately the denominator cannot be 0. So in order to find out what makes it 0, we set it equal to 0. So if I kind of a little side note here, my denominator is 7a to the third, and I'm going to set it equal to 0. Okay, so this is us finding the excluded values. And I guess I can even, maybe it would help if I write right here, denominator equal to 0. Okay, so if they just want you to simplify it, you can just give the 3 over a. But they're not just asking us to simplify it, they're asking for excluded values. So 7a to the third equals 0. How do I solve for a? If it's 7 times a to the third, the first step is to divide. 7's cancel. A cubed 0 divided by 7 is 0. 0 divided by anything is 0. And officially, it's a to the third. How do you get rid of a third power?
You can.
A over 3.
No.
Okay, subtract 1, do the thing, and then. I don't know.
I'm just subtract 1, do the thing. I'm like, what thing?
That's what I was.
Okay, so let me ask this. What if it was a squared? How would you get rid of the squared?
Do x squared.
We would take the square root. Okay, so officially, we would take the cube root here. Now, here's the deal. A cubed equals 0. If a times a is 0, what does a have to be? 0, right? So if you, officially you could say take the cube root, but it just turns out to be that a is 0. So that is our excluded value, okay? We just found, when we did that, a equals 0. So really what we're saying here is that a cannot equal 0. Okay? So that was an example. There's just one term on top, one term on bottom. We did more of just a reducing the fraction, right? Dividing by common factors. In order to find your excluded values, it's always going to be denominator equal to 0 every time. Okay? Let's try example 2. 18d squared over 4d plus 8.
2. Or 2d.
Okay. So, well,
It's not plus 8. I don't know if you look at the,
so you say 2, because what are we noticing? 18 divides by 2, 4 divides by 2, and 8 divides by 2. 4 and 8 both divide by 4, but 18 doesn't divide by 4. Okay, so they can all divide by 2. Now the question becomes, is there a d associated? Well, 18d squared divides by d. 4d divides by d. Does 8 divide by d?
No.
No. So what's the only thing they all have in common?
2.
Is a 2. Now, and you can do this, because I know what you're going to say you want to do is just divide by 2, divide by 2, divide by 2, there's your answer. And I'm fine with that. That works. But I also want to show something else, because as we get down these, we're going to have to start talking about factoring. This all relates to factoring. So, what I'm going to do here, in the denominator, I know it's not the GCF, but if we factor out a 2, what remains in the parentheses? So,
4d plus 8.
well, but 4d, if we divide that by 2, becomes 2d. Plus 8, if we divide that by 2, becomes plus 4. On top, we have 18d squared. Well, if we factor out a 2, that's going to be 2 times what?
9.
Yeah,
9d squared.
9d squared. Now, the reason I write it like this is I want you to realize there's 2 times something on top, 2 times something on bottom, so those 2's can cancel. If those 2's cancel, what remains?
9d squared over 2d plus 4.
9d squared over 2d plus 4. And that's your simplified answer. Now, if you're looking at me and saying, I don't like that factoring the 2 out, I just divide everything by 2 and I got the same answer, that's okay. That works. Okay? Now, do I get to move on?
Hold on, write that down.
That's right, I'm not moving on anyways, because
You know, like actual like movement.
no, I still have to do what on this problem?
Oh, so
No, we simplified. Now we have to find
Excluded values.
excluded values.
that's
Okay, so there's two parts on all of these, and I set up Math Excel like end of last week, so I don't remember how it's set up, but in order to do this, we're going to set our
So the denominator equal to 0.
denominator equal to 0. What was my denominator?
4D plus 8.
4D plus 8. So I'm going to take my denominator right here, set equal to 0. Okay, how do we solve if it's 4D plus 8?
First of all, subtract 8 from both sides.
Yeah, if it's plus 8, we're going to start by subtracting the 8. So then 4D remains.
Divided by
8 minus 8 cancels. What's 0 minus 8 over here? Negative 8. Then, if it's 4D as in 4 times D, we're going to divide by 4. 4D divided by 4.
D.
4's cancel and we have D. Negative 8 divided by 4.
Negative 2.
Negative 2. What is that? This is my
Excluded value.
excluded value. Okay, so yeah, we solved it, came up D equals negative 2, but what it really means,
Is that it?
D cannot equal negative 2. Because here's the deal. If I put negative 2 in here, 4 times negative 2 is negative 8. Negative 8 plus 8 is 0. You can't divide by 0. If you try and divide by 0 in your calculator, it's going to tell you error. Okay? So that is the excluded value.
I don't understand why you would ever need to know the excluded value. Like, what's the point of knowing what doesn't work?
If you're coming up with answers and you try and say that, one of the answers is negative 2, you need to realize, that it doesn't really work because you can't have 0 in a denominator. There's reasons along the way, I promise. Okay, let's try another one. Now, as we move through this page, we need to think factoring. Okay? We need to think factoring. Do you see any factoring in this next one? There's 2n minus 3.
There's 6 and 9.
There's 6n minus 9. How can we factor this? Okay, 6n minus 9, both of those divide by 3. So, what if I throw the phrase out there, GCF?
Yeah,
Greatest common factor? Yeah, we haven't moved past those. You were hoping we had. So, on the bottom here, we have a GCF. 6 and 9 can both divide by 3. Now, that means you put the 3 out front, and we start our set of parentheses. 6n divided by 3. 2n minus, and do the same thing with 9. 9 divided by 3. Yeah. So my denominator of my problem just became 3 times 2n minus 3. Numerator. Jacob saw the 3 in the bottom, so I went with it. What about the numerator? 2n minus 3. Is there a GCF up there?
There's one.
There's always a 1, isn't there?
Yeah.
Now, I'm actually going to use that 1 this time.
Alright.
Normally, I don't use the 1. I just like, it's the same, which it is the same, but it'll help you see your answer better here. If I factor out a 1, okay, humor me here. 2n divided by 1 is still 2n, right?
Yeah.
Minus 3 divided by 1 is still
3.
the minus 3. There's a reason I did that. My top is factored into 1 times 2n minus 3. My bottom is factored into 3 times 2n minus 3. Are there any common factors that I can cancel here? Yeah, don't we have a 2n minus 3 on top and bottom? You know, this last problem we had a 2 top and bottom. Here, we have a 2n minus 3 that cancels with a 2n minus 3. What remains when I cancel those 2n minus 3's? 1 over 3. Thus, I wanted to use the 1 this time. Here's what you have to remember. What if we hadn't used that 1?
It would have just been 3.
Well, no. We still would have had 3 in the denominator. We still have to have something in the numerator. And the rule is, if everything cancels out in the numerator, there's still that invisible 1.
Oh, yeah.
So you still have to put the 1 there. It made it easier for us to put the 1 there, though. Okay? Definitely made us easier. Let's see. Do we have time for one more?
We have 8
No.
minutes.
It depends. Are they going to do the announcements or are they not, right? We'll see what happens. Oh, wait. I'm not done with this one.
Oh yeah. Gotta get your
Excluded values.
Excluded values. You guys almost let me forget those. How rude. Okay, so we're setting our denominator equal to 0. Which probably the easiest thing is to set probably just the 6n minus 9
Yeah.
equal to 0. Okay, how do I get n by itself? If it's 6n minus 9, we're going to add 9.
Yeah.
So we add 9. 0 plus 9 is 9. Hard math, huh? How do I solve for 6? Or how do I solve for 6? How do I solve for n?
Divide by 6.
If it's 6 times n, we're going to divide by 6. And then
And it equals 9 over 6.
n equals 9 over 6. Can you reduce 9 over 6?
I mean, you could, but
What do 9 and 6 both divide by?
3.
3.
3. So 9 divided by 3 is 3. 6 divided by 3 is 2. So 3 halves, which is also 1.5, but so this says that n cannot equal 3 halves. I don't know what form Math Excel will want their answers. Whether they want that as a fraction or as a decimal.
Probably fraction.
I feel like fraction. And I feel like if you put 9/6, they'd call you wrong because you didn't reduce.
Yeah.
So that's why I kept us going to 3 halves.
Okay. Beautiful. Out of time.
In a normal class, I'd say let's do the next one. But are the announcements going to come on and interrupt us?
I think so.
You think so? We'll see. Now today, watch, they won't. Okay, so we will plan e-learning as IXL tomorrow. Okay, the Math Excel assignment will probably be open on this if you want to start looking at it. But then Monday we'll finish the notes. And we have what? There's like 5 examples left, so you might be able to get some work time out of it too. And then the homework will be due on Tuesday.